Video number 16 plus. Hidden mass and ghost light. Hello everyone. In the previous video, number 8 plus, I mentioned the so-called dark matter problem, initially called by Zwicky the hidden mass enigma. Of course, a distant matter that does not emit any radiation is invisible for us, but, as we shall see now, other forms of hidden mass can also be considered. Recently, around some galaxies, very large gas clouds have been discovered, which could be part of the hidden mass and whose presence could contribute to the excessive rotational velocity of stars at the edge of the galaxies and that of galaxies within clusters. As the mass of these clouds is not enough to explain the observed phenomena, research went on for an exotic dark matter called non-baryonic, although for several decades nothing has been discovered in this direction. And recently we've been told again about another enigma, that of the ghost light, also discovered by Zwicky, a kind of diffuse light emanating from intergalactic space in the clusters. Thanks to the Hubble Space Telescope, some wandering stars would have been discovered in these areas, at least around the Milky Way. It was speculated that these stars, expelled from their galaxies, could be the source of the ghost light. Before going any further, I would like to give an elementary reminder of how the stars are perceived from the Earth. First of all, the luminosity of a distant object, therefore with a reduced apparent diameter, is, for a given absolute brightness, inversely proportional to the square of the distance to the observer. For a given star, if the distance is multiplied by 10, the quantity of light received is divided by 100. For stars and planets, we define the notion of relative magnitude to describe the luminosity, which is obviously the same in any point of the globe, as long as the object is observable. Some stars, for example, are only visible in one hemisphere, such as the pole star in the north and the stars of the Southern Cross in the south. By convention, the magnitude increases by 1 when the apparent luminosity is divided by 2.5. This convention was introduced in 1856 by the astronomer Norman Pogson to extend the tradition of ancient Greek observers for whom a difference of magnitude of 5 points corresponded to a factor of 100 at the level of apparent luminosity. The three stars Arcturus, Vega, and Alpha Centauri have magnitudes close to 0. For example, Alpha Centauri is 4 light-years away from us, and it is a medium star slightly brighter than the Sun in absolute magnitude. If a star comparable to Alpha Centauri were 4 million light-years away from us, its magnitude would be a number small m such that 2.5 to the power m equals 10 power 6 square equals 10 power 12, which means that small m is equal to 12 divided by the decimal logarithm of 2.5, approximately equal to 12 divided by 0.4, equal 30. Why this calculation? It tells us that average stars locating more than 5 billion light-years away from us are invisible even for space telescopes, whose resolution limit is around magnitude 30. Having seen this, I asked the following question to a group of cosmologists I connected to. Could it be possible that ghost light actually originate from a large number of stars located outside galaxies and invisible for us due to distance? In response, I was sent an article by the two astronomers, Ju and Myung-guk James G, showing that ghost light already exists around very distant galaxies corresponding to a very remote time in the past. If these stars were expelled, they had very little time to be created within the galaxy, as has been assumed so far. We are then led to ask ourselves two fundamental questions. Question 1. Is a significant percentage of invisible matter composed of stars that are too distant to be distinguished even by our best instruments? In this case, it is no longer dark matter, and one wonders if dark matter is still useful to explain the observations. Question 2. Are we sure that the orphan stars have been expelled? Or could it be that, on the contrary, the stars were created before galaxies, which would then be the result of a continuous process of gravitational grouping of isolated stars? It is to be hoped that future observations from the James Webb Telescope will reveal more about the creation of stars, galaxies, and clusters. To be continued.